Hello children, today we are going to learn about trigonometric ratios. So before we start trigonometric ratio, what is the meaning of trigonometry? Trigonometry is nothing but this is the combination of two words trigon and metry, where trigon is three-sided polygon which is a triangle and metry is measures. So when you take a right triangle and you are finding about the unknown sides, unknown measures of the triangle, then it comes under trigonometry. Now, in this lower grades, you take only right triangle, but in higher classes, you can have trigonometric using non-right triangle also. So, till now, what do you know first? You already know about if there is a right triangle. If there is a right triangle, if I'm taking a right triangle, what is the rule you already know? We know Pythagoras theorem. And what is the Pythagoras theorem? If I'm taking here three sides, it's a right triangle which is right angle at angle B. So Pythagoras theorem is true for only for a right triangle. So my prerequisite is here angle, one of the angles should be 90 degrees. So it should be a right triangle. Now what is the side opposite to 90 degree? If I consider here, this is the 90-degree angle and the opposite side is AC. That is already always known as hypotenuse. So side opposite to 90 degree, we call it as hypotenuse. That is nothing but the longest side of the triangle. So this is your hypotenuse, which is always going to be always opposite to 90 degree. The other two sides, so using Pythagoras theorem, so you know that we can apply Pythagoras theorem which states that the square of the hypotenuse, and what is the length of hypotenuse here? AC. AC square is equals to AB square plus BC square, which is nothing but the sum of square of the other two sides. So this rule we use to identify the unknown measures. So when can we use this Pythagoras theorem? When any two sides are known, then you can find out the length of the other third side, right? But what happens if I don't have the length of two sides? How are you going to find out the measure of other any of the unknown side when one angle is given and one side is given? Before we take this, let us see here. Whenever we are having a right triangle, one of the angle is always 90 degree, right? So if one of the angle is 90 degree, what about the other two angles? If I'm taking here, this is again I'm drawing one right triangle, right? Here if I take triangle ABC, now angle B is 90 degree. Then what are angle A and angle C? Angle A and angle C are acute angles, right? So we learn the trigonometric ratio using these two acute angles. So this is angle A and this is angle B. Another thing you should know, these angles, sometimes we take the variables as theta. This is, we call it as, this is the new word for you. This is angle which has been taken as theta, or sometimes they take it as alpha or beta or gamma, right? All these are taken as the variable. Then this is gamma. Okay, so in general we take theta. So if I mark any one angle, angle A as theta or angle C as theta, so we take trigonometric ratio of only acute angles, correct? So let us start. What is the meaning of trigonometric ratio? So ratio, you know that it is nothing but you have to take any two sides. Trigonometric ratios, there are total 6 different ratios. 3 of them are the basic ratio and the other 3 of them are their reciprocals. So what is the first ratio? We'll take it here. We take here sine of an angle, right? An angle, and that angle, it can be any one acute angle. It can be angle A or angle C, or we write down this in the short form as sine theta. Now look at here. If I mark here angle theta, angle C here, it is theta. So how do I find out? Then the other trigonometric ratio, we take it as cosine of the angle theta, which is in short form written as cos theta. Then we take it as here tan theta. Now tan theta, when you take it, it is tangent theta, where the short form we write down as tan theta. So this is tangent of an angle, which is this, and we can short form it is tan theta. Now I'm saying these are the trigonometric ratio, but how are you going to take it as a trigonometric ratio? So you have to remember one mnemonic, which is written as SOHCAHTOA. SOHCAHTOA. Using this, it's very easy to remember. Here S represents here sine, right? Here C represents here cos or cosine, and here T represents tan. And what is O and H? Whenever we take an angle, right? Now, if I'm taking here angle theta, first you need to identify what is O. Here O stands for opposite. So every angle, if you will see, if I'm taking angle C here, it is the angle between AC and BC, right? So this is the one of the side is hypotenuse, which is side opposite to 90 degree. So whatever is here with respect to theta, this place is fixed, which is known as hypotenuse with respect to theta, because, and this is called adjacent. So here A stands for adjacent side of the angle, adjacent side of the angle, and O represents opposite side of the acute angle. Now, how do we take it here? This is with respect to theta, this is adjacent, this is hypotenuse, and the other third side, which is opposite to theta, we write down as opposite. Okay. Now, how do we take it? How do we use this SOHCAHTOA? If you will see here, the first one is if I write down here sine theta, which is angle C. So sine theta is nothing but opposite by hypotenuse. So you can see here this word sine opposite by hypotenuse. Cos is adjacent by hypotenuse because this is a ratio, and tan is opposite by adjacent, right? So what is the opposite side to theta here? It is AB, side AB, and hypotenuse is AC. So sine theta is AB by AC. Similarly, if I take cos theta, it is adjacent by hypotenuse. Now, what is your adjacent with respect to theta? This is the side which is one of the arm of the angle is called adjacent, right? So here, what is your adjacent side? It is BC by AC. And if I take here tan theta, then here tan theta is opposite by adjacent, and if I see opposite is AB and adjacent side is BC. So these are the three basic trigonometric ratio. Then what are the other three ratios we use? Those are nothing but the reciprocal of these trigonometric ratios, right? So let us take here, if I consider this triangle again, this is the triangle, and if I'm talking about so these are the three basic trigonometric ratio. Then what is the reciprocal ratios? Okay, reciprocal of trigonometric ratios. So cosecant. This is called cosecant of theta, which is the short form we write down as cosec theta is the reciprocal of sine theta, or sine theta is the reciprocal of cosec theta, right? So how can we write down? The product of sine theta times cosec theta is always 1 because they both are reciprocal of each other, right? Similarly, so this is our first one. What is the second reciprocal? We'll have it as here. So cosec theta, if I want to take the ratio, then I can take it here cosec theta is hypotenuse by opposite, because sine theta is opposite by hypotenuse, right? The second one, if we take it here, secant of an angle, and the short form we write down as sec theta, which is nothing but the reciprocal of cos theta, or I can cos theta is reciprocal of sec theta, or the product of both is going to be cos theta, and sec theta product is always 1. This is your second reciprocal. Okay, these results you have to remember, because while proving the identities you are going to use it. The first result is this, second result is this. Then what is the third reciprocal we are going to take it? The third reciprocal is cotangent of an angle theta, which is written as short form is cot theta, which is nothing but the reciprocal of tan theta, right? And here, or I can write down here, tan theta is the reciprocal of cot theta. And what is going to be their product? Tan theta times cot theta is always 1. This is your third result. Now, other than this, if I want to write down as a ratio, then you know that cosec theta is hypotenuse by opposite. Then what is going to be your secant sec theta? It is nothing but the reciprocal of cos theta. Cos theta is adjacent by hypotenuse. So sec theta you can write down as hypotenuse by adjacent. This is your second result, right? Then similarly, cot theta is the reciprocal of tan theta. So I can write down in terms of ratio, cot theta is adjacent by opposite. So the basic three trigonometric ratio, if you remember, these three you can identify or you can derive using the basic three trigonometric ratios, right? Then what is the short form, shortcut way to remember this? Because sometimes we may forget it. So remember, there is a hexagon here which we can use here. This is the another short form. If we use hexagon, it's very easy to remember these reciprocals. Now look at here, if I draw a hexagon, the hexagon is a six-sided. This is the shortcut way to remember, and here this. So first, please do not change the places here. Write down in each end here sine theta opposite is cos theta. Then here tan theta opposite is cot theta. And then here sec theta opposite is here cosec theta. And at the center you need to join, and at the center you will be writing as 1. Now how do we use this hexagon? You will see that here, right? First thing you should remember, if I want to use the reciprocal, join the opposite sides. Now look at here, 1 by, here if you use this hexagon opposite side, 1 by sine, you can see that here this is the opposite side. If I take 1 by sine is cosec, 1 by cosec. If I take this 1 by cosec, it is sine, right? Similarly, 1 by sine, that is going to be cosec. What is the opposite on other side here? Cos and sec. If I am taking here, similarly, 1 by cos is sec theta, 1 by sec theta is cos theta. And if I take cot tan and cot are opposite, 1 by tan theta, here 1 by tan theta is going to be cot theta, and 1 by cot theta is going to be tan theta. So this is the easier way to remember the reciprocal. And you can, if you want to take it as a product, then here you can say that sine theta into cos theta is 1. Similarly, sec theta into cos theta is 1. Cot theta into tan theta is 1. So hope you got this. Have a good day. Thank you.
Thank you for watching this video. Please like, share and subscribe. Also, keep practicing.